Hello everybody, my name is Juan Toro, I'm from Colombia, and in this video I'm gonna showcase my final project for the course CS50SQL from the Harvard University. And this is kind of a continuation of my final project for the CS50 Python course as well. So back in that final project, I built a personal finance application, or more exactly, a personal finance CLI tool. And I didn't have any database back then, so all the data was being saved into a JSON file. So when I was thinking about this final project, I thought, well, it'd be really great to have a database for that application, so that kind of the next level. So that's how basically this idea was born. So let's get into it. So this is the schema or my entity diagram. So we have different entities, as you can see. We have an entity for banks, for accounts, for transactions, for users. So basically, just one example is that a user can have zero or many accounts, and an account can have zero or many transactions. So that's how basically I build this entity diagram. One interesting thing to note is that we have tags. So let's say that a transaction can have multiple tags. That's why I had to create this junction table called transaction tag to represent that relationship between transaction and tags, because a transaction can have more than one, zero or more tags. So that's why I have to create this junction table. And I also created this other kind of self-reflecting table, so that we kind of represent the conversion rates, because my database supports more than one currency. At the moment I'm supporting euros, dollars, and Colombian pesos. So that's why I had to also create this table to sort of store that conversion rates. Over here I have my design document, where I basically explain the scope, the functional requirements, everything about the entities. So if you wanna get full details, a full explanation of what I'm talking about, I would recommend you checking this document out, because everything is here. I did a extensive job documenting as detailed as possible. So please give it a look if you wanna understand each entity better. It's also interesting to know that I created some indices. So I can show you my schema. So we have over here all the tables that I just show. And then over here, I created also some tables, some views, some views. I created some views. And then we have over here some indices. So I created these indices thinking about how would be the kind of the most frequent queries in the application. So that's why I created, for instance, this index that basically normally you would query the application on certain account and also certain date. So let's say that you want to query what were the transactions of this account in these dates. So that's how I ended up creating this index. Other common query is using tags. So let's say that you want to check how much money you spent last month in food. So for that, you would query the database by filtering on the tag column. So that's why I also created that tag, that index for this attribute, for the tag attribute, or for the tag table. I also created some regarding the user ID. So let's say that you want to query all the accounts for certain user, and even budgets. So how many budgets we have on certain accounts, or you want to filter on certain budget from certain accounts. So that's why I also created this kind of indexes. This is also documented in this design file. There are some limitations in my current database as well. One of the most important limitation is that I'm not supporting uh, the conversion rates at real time, because for that I will need to set up some kind of API integrations. I will need obviously an application layer to sort of update the database in real time. So that's why the conversion rates were inserted as of the value for today. Um, what else? Well, the triggers. So yeah, this is very interesting. So I had to create a lot of triggers so that the balance is always keep it up to date. Is always updated based on the transactions. So if a transaction is an expense or an income, so if it's an income, the value will be summed up to the balance of the account. If it was an expense, it will be subtracted from the from the account's balance. So that's why. So this is interesting because normally you would calculate the balance on the fly. So you would aggregate all these transactions, and depending and you would sum up all the incomes and you would sum up all the expenses, and then you would basically subtract all those expenses from all those incomes, and you would end up having the balance, right? But for a small application like this one, that's not a problem. But if you want to scale it up at an enterprise level, well, that's not ideal, because you would end up aggregating thousands or even millions of rows just to calculate the balance, or just to check that, let's say that you are not having a transaction when you don't have actually money on your account. Um, so that's why I decided to use triggers, even though it was a pain to create them because they are a lot. But I think it's worth it, because now moving forward, my application will not need to worry about calculating the balance and everything. All of that is being handled by my database using these triggers. Um, and that's kind of the idea behind these triggers. So yeah, that's pretty much it. As I said, everything is explained in this document, so please give it a look. Also, the diagram is here. So yeah, that's all. Thank you so much. I almost forgot, in the queries SQL file, you will find kind of most common queries that you will do in this database. So yeah, thank you so much.